Hi and Assalamualaikum. We are from 5E and Group 4. Today we will present about assignment MEV321. Before we go further, here is an overview for our video presentation. My group consists 3 members. The first one is myself, Naufal, and second one is Alia, and last one is Shahazi. And this is work distribution amongst group member. I will explain the history and development of the drivetrain. We start in late 80, where internal combustion engine or ICE was first introduced. This invention became the foundation for the earliest vehicles and became the starting point for all future improvements in drivetrain technology. Moving to the 1930, the automatic transmission was introduced. This new system made driving much easier for everyone because it removed the need for constant manual gear shifting. Next, in the 1980s, the 4-wheel drive system became more common. This technology provided cars with a better traction, improved grip, and overall better control, especially in challenging driving conditions. Then, in the 1990s, hybrid drivetrains were developed. This system combined a petrol engine with an electrical motor, which helped reduce fuel usage and lower emission. Finally, in the present day, modern powertrain technologies include the dual-clutch transmission. This system allows very fast and smooth gear shifting, making the driving experience more efficient and responsive. Next, I will explain the history development of clutches. We begin in the 1920s when the first clutch was introduced. This was an important milestone because the clutches allow smooth gear change and improve the overall driving experience for early vehicles. Next, in the 1930s, the automatic clutch was developed. This technology removed the need for manual clutch control, making driving much easier and more convenient for users at that time. Moving forward to the 1950s, the diaphragm clutch was introduced. This system provides a more reliable and efficient clutch mechanism, offering better performance and improved durability compared to the earlier designs. Then, in the 1980s, hydraulic clutches started to be widely adopted. The hydraulic system offers smoother and more precise control of the clutch, while also helping to reduce wear and tear on the clutch component. Finally, in the 2000s, dual clutch transmission system, or also known as DCT, were introduced. This modern system provides very fast and efficient gear change, performing much quicker than traditional clutch systems and improving overall driving performance. Now, let's look at the history and development of the torque converter. The evolution of torque converter began in the early 1900s. At this time, the fluid coupling concept was first introduced. This early design allowed the engine to maintain a constant speed while still providing variable output speeds. This was the foundation for what later became the torque converter. Moving on to the 1920s to the 1930s, during this period, Hermann Fontinger developed the first particle fluid coupling. His design was mainly used in ships and later adapted for train and early vehicles. The key advantage was smoother operation compared to the mechanical coupling, which made it an important innovation in power transmission. Next, in the 1940s, the stator was introduced, which is the component responsible for torque multiplication, something that basic fluid coupling could not provide. This marked a major step forward in improving vehicle acceleration and efficiency. Around the same time, General Motors began incorporating torque converters into their early hydromatic automatic transmission, helping standardize the technology in the automotive industry. Next, we move into the development from 1950 to the 1960s. During this period, torque converters became common in automotive transmission. Most of the innovation focus on improving the design, making the device more durable and enhancing their overall efficiency. This helped automotive transmission become more reliable and widely accepted. Then, in the 1970 to the 1980, the lockup torque converter was introduced. This was a major milestone because it reduced fuel losses that normally occur in traditional torque converters. With the lockup mechanism, vehicles gain better highway efficiency and produce less heat, which made the system more effective and economical. Moving on to the 90s up to the present, torque converters become more compact, stronger, and more efficient. During this period, electronic transmission control were integrated into the system. This allowed better synchronization between the engine and the transmission, resulting in a smoother gear shift and improved overall vehicle performance. Finally, let's look at the current trend. With the rise of electrical vehicle, the role of the torque converter is changing. EVs generally don't require torque converters, but the device still plays an important role in many hybrid systems and modern conventional vehicles. So, even though the automotive landscape is shifting, the torque converter remains a crucial component in many drivetrain designs.
First, I will explain the powertrain of the Volvo XC40 T5, which is a traditional internal combustion engine vehicle. The XC40 T5 uses a 2.0-liter turbocharged petrol engine. Its main function is to convert fuel into mechanical power, and this power is then transmitted to all four wheels through an 8-speed automatic transmission and AWD system. Because it uses an automatic transmission, the vehicle relies on a torque converter instead of manual clutch. This helps deliver smooth acceleration. The concept of the ICE powertrain is based on a fuel combustion inside the cylinders. This process follows the Otto cycle, which involves 4 strokes: intakes, compression, combustion, and exhaust. The energy produced from the combustion moves the pistons, rotates the crankshaft, and finally sends power through the drivetrain. With the AWD system, the T5 distributes power to all 4 wheels. This improves traction and stability, especially on slippery roads. Although it adds some weight and causes minor energy loss, overall, the ICE drivetrain has a one-direction energy flow, from fuel to the engine, to the transmission, and finally to the wheels. Next, I will explain the Volvo XC40 Recharge plug-in hybrid, which combines a petrol engine with an electric motor. The main function of this hybrid powertrain is to provide multiple driving modes, such as EV only, hybrid mode, engine only, and regenerative braking. This setup allows the car to improve fuel efficiency and reduce fuel consumption by using electric power whenever possible. Unlike the ICE model, the hybrid system needs to disconnect the engine during EV-only mode. To achieve this, a separation clutch is used between the petrol engine and the drivetrain. The concept of this vehicle is a parallel hybrid system, where both the engine and electric motor can drive the wheel. In this model, the front wheels are powered by a petrol engine, while the rear wheels are powered by an electric motor, creating an electric-based AWD system. The battery supplies energy for EV driving, and regenerative braking recovers energy when slowing down. Some important mechanical theories include, which is parallel hybrid architecture, where the engine and motor can work independently or together. Regenerative braking, which converts braking energy into electricity. And electric motor torque, which provide instant torque from 0 RPM, improve acceleration and response.
Next is the discussion part. We have 2 questions to answer. The first one is explain the development of drivetrain based on model vehicles ICE versus hybrid. The second one is describe how clutch in ICE and torque converter transfer the power from engine to the transmission.
Describe how clutch in ICE and torque converter in hybrid transfer power from the engine to the transmission. First, internal combustion engine ICE for Volvo XC40 T5. The clutch in a manual transmission car transfer power from the engine to the transmission through frictional between the flywheel, clutch disc and pressure plate. When the clutch pedal is released, the pressure plate clamps the clutch disc tightly against the spinning flywheel, causing the disc to rotate at the same speed as the engine. The center of the clutch disc is splinted to the transmission input shaft, so that the disc turns, it drives the input shaft and delivery power into the gearbox. When the clutch pedal is pressed, the releasing bearing push against the pressure plate's diaphragm spring, lifting the pressure plate away from the clutch disc. This releases the disc from the flywheel, allowing the engine and transmission to spin independently. This temporary separation enables smooth gear shifting without grinding or damaging the gear. Next is hybrid vehicle. For Volvo XC40 recharge plug. In a hybrid with a torque converter, automatic transmission happens. The engine crankshaft spin an impeller pump inside the torque converter. The impeller pushes transmission fluid outward by centrifugal force toward a turbine that is connected to the transmission input shaft. As the fluid strikes the turbine blade, it forces the turbine to rotate, sending power into the transmission. A stator position between the impeller and turbine redirects the returning fluid to increase efficiency and provide torque multiplication at low speed. At higher speed, a lock-up clutch inside the torque converter engages, creating a direct mechanical connection between the engine and transmission to reduce slip and improve efficiency. This system allows the hybrid engine to deliver power smoothly while blending in the electric motor. Volvo XC40 T5 versus Volvo XC40 recharge plug. First, in terms of working principle, the XC40 T5 uses only a turbocharged petrol engine. Its power goes directly from the engine through the gearbox to the wheels. Meanwhile, the recharge plug-in hybrid uses both of petrol engine and electric motor. Power can come from the engine, the electric motor or both at the same time. The hybrid model also has a battery that can be changed using a plug. Next, when we look at the performance, the T5 gives strong petrol power with a smooth acceleration, although there may be some turbo lag at low RPM. On the other hand, the plug-in hybrid benefits from instant torque for the electric motor, which gives quicker response at low speed. Its overall combination power is slightly higher or almost similar to the T5. For efficiency, the T5 has higher fuel consumption because it relies fully on petrol. The plug-in hybrid is much more efficiency, especially in city driving. It can also drive around 40 to 45 kilometers using only electricity. Finally, for driving comfort, the T5 gives a traditional petrol engine feel. With more noise during harder acceleration, it is also lighter in weight. The recharge plug-in hybrid is very quiet and smooth when driving on electric mode. It provides seamless low-speed driving and feels more refined overall, although it is heavier because of the battery. In summary, the T5 offers classic petrol driving experience, while the plug-in hybrid provides smoother, quieter, and more efficiency everyday driving.